Hello. In this video, we'll talk about linear transformation and geometric properties of those transformations. We start with the following definition. A function t from v to w is called a linear transformation between two vector spaces v and w if it preserves both vector addition and scalar multiplication. So we have t applied to the sum of the vectors v1 and v2, giving us the sum of their images in w, and likewise t applied to the scalar multiplier times the vector v1 gives us scalar multiplier times the image of v1 in w, and this holds for all vectors v1 and v2 in v. Next, we'll discuss an important property of linear transformations for the Euclidean plane R2. So it's formulated as a theorem which says a function t from R2 to R2 is a linear transformation if and only if there exists a 2 by 2 matrix A such that t applied to V gives us the product of the matrix A and the vector V for all vectors V in R2. Related to this theorem, we have a definition. This definition defines the matrix A, which we have in that theorem, and we say that the matrix A is called the standard matrix for the linear transformation T, and its two columns are given by the result of the application of T to vector 1, 0, which is the first basis vector in R2, and the second column is formed by T applied to 0, 1, which is the second basis vector in R2. And finally, we will consider some examples of linear transformations. So we'll talk about linear transformations that reflect vectors about the x-axis, and this is the first transformation, which is associated with the matrix A1. The second transformation reflects vectors about the y-axis, and it's associated with the matrix A2. And finally, if we reflect vectors in the line y equals x, then this transformation is defined by the matrix A3. So if we wish to illustrate graphically those transformations, then in the first case, we think about vector, which is reflected about the x-axis. So we drop the perpendicular and have the reflection here. In the second case, we talk about reflection in the y-axis. So we'll have the vector, which is somewhere here, and it will be reflected about the y-axis. So we drop the perpendicular here, and we'll have the reflection like this. And finally, if we talk about the third example, then we have the line y equals x, which is the bisector of the first quadrant. And then the reflection of the vector will be obtained in a similar manner by dropping the perpendicular onto that line. Thank you very much for your attention.